Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. This is part 2 of this Ruthless Audio 4500 board. The power supply, I've got the new drivers installed, and I've got the 3205s installed. Pulled out all the output transistors. Of course, if you lose one, I replace them all. I lost one on each, so, you know, that's every transistor, which is good practice anyways. You have both sides of the aisle when it comes to what you should and shouldn't replace. But go with your instinct. Replace what you think should be replaced. Goodbye, AI. Alright. Just messing around, guys. Okay, because I'm just really testing to see, is this thing still going? Yeah, bitch, still going. She's heating up. Yesterday the thing was locking up on me, so yeah, let's just get everything going. We're gonna test out this whole new setup here. Let's get this scope fired up. Where are we at here? Regal. This is the DS1054Z. It's a 4-channel scope. It's I would call it an entry-level scope. You don't need anything other than entry-level to do what we do what I do, to do this kind of work. You just need a scope that'll show you a signal in reality. That's really all you need. Alright, so we got a camera here, we've got the scope here, we got this camera running, we got that camera running. Oh, it's backwards. Hold on. Okay, that'll work for me. I mean, if I have to, I can flip things over, but I think we're good here. Of course, I'll look for your guys' input. Let me know. Is my scope running? So we have a scope going, we have power going. The very next thing I check when I'm rebuilding an amplifier, I don't remember if I said this on the last video, but I do this in sections. Treat the amplifier in sections. It's much easier, it's quicker to repair it that way than to be jumping back and forth, because what you think may be wrong here, cause an issue here, is not really how that works. So if you take this amplifier and cut this bad boy right down the middle, you're going to have a power supply, switch mode power supply on one side, and you're going to have an output section on the other side. It just takes your DC rails, positive and negative, takes a preamp, swings that signal from the positive and negative rails. But if you cut this thing right down the middle, this will run by itself. This, when there's an issue, will tell this to turn off. But when you don't have an issue here, this will run by itself with no transistors in the output. You won't get any. You'll get a brief signal until it doesn't see any feedback and shuts down. Yeah, on these other ones that use the 640Ns but don't use the 2184 IC, you can get a low side drive that's constant. But in this situation, my primary goal right now is just to make sure this power supply is alive and well within its specifications of amplitude and frequency. So what I'm going to do is make sure nothing heats up. I don't care what the rail voltage is right now. I don't care what anything. The only thing I care about is if it's getting hot. So I'm going to go ahead and turn the power on. I got my FLIR TG167 here. This is an old thermal imager. I don't even know what year this was made. This is an older one. Yeah, it does the job. It serves its purpose. Finds my hot spots. But I'm just gonna go ahead and we're gonna fire this up make sure there's no heat. My primary goal right now is just to make sure that none of my power supply transistors are heating up. Click, and there goes the relay. As I said, this power supply will run by itself. So we have a power supply. I've got my plus minus regulators are running on the output section, so I know I have rail voltage and I don't have any heat on the transistors. And that's what I'm looking for, is I'm just looking for heat on those transistors. Making sure nothing is overheating. Yeah, there is no thermal signatures on those power supply transistors. So that's telling me I'm good to check my signal, my frequency, my amplitude. Frequency on these is anywhere from what, 25 to 27 kilohertz. And the amplitude is probably going to be your average 6 volts. Let's go ahead and find out. Alright, so I have it there on the screen for you guys. Our power supply is running at 25.8 kilohertz, so yeah, about 26 kilohertz. And we are an amplitude of 5.6 volts. Looks great. Voltage peak to peak at 10.8. There's no excessive overshoot. It's getting pulled real hard to ground, as you can see there. Yeah, as you can see, the spike to the ground, it's telling me that the gate's getting pulled to ground and getting turned off completely. We can check the drain to see if there's any ringing. So what I'm going to do, hold on, I don't want to blow my scope up here. Let me just keep in mind that your rectifiers are going to have rail voltage on it. So if you're going to be probing or hooking onto anything at the rail here, what is the rail? It's sitting. The rail, it's discharging. It's at 25 volts right now, which is good. It means these discharge resistors are doing their job. But I'm going to reach right in here. This is the doubler. So I'm going to reach right in here. I'm going to put my probe on the AC side of this rectifier. Increase my voltage, of course, because it's going to be peak to peak on the secondary side of the transformer. And there's the rectifier. So that is the input side of the rectifier. So there's no ringing, no overshoots. That is what I would consider a really clean, good-looking square wave going into the rectifier. Then from there, it gets rectified into your plus minus voltage, which you can see on the board. It's labeled on the board, negative over here, positive over here. So my power supply is exactly where I would want it to be. And at that point, I have no concerns about the power supply. I mean, obviously we check for loose items, you know, vibration damage and whatnot, which these windings are just notorious, not particularly for this transformer, but on other, like the big Korean boards, your auxiliary windings are notorious for shorting out. So, yeah, power supply is good to go. So this is part 2, power supply. Part 3 will be the complete output section. I'll put that together, and then we'll fire this whole thing up, and then test the signals on the output. So yeah, thanks guys, as I work through this new equipment once again, and hopefully get you guys a better viewing experience. Thanks for watching. We'll catch you on the next one.